Okay, Mary Berry, this video is for you. I saw your question on Reddit. Is this limit solvable? The limit as a approaching infinity of a times a's root of x minus a. For this question, we have to keep in mind, a is the variable that goes to infinity. So x is like a constant. I know it's weird because usually x is the variable, a is the constant. But let's just deal with this like this. All right, firstly, I'm just going to factor out the a, and then you'll see that it's actually easier to see what's going on after that. So let's go and do that. Limit as a approaching infinity, and we will have a. And then this right here, let me actually write it in the power form. Whenever we have the index here for the radical, this right here is the same as x to the 1 over a, whatever this number is. If you have 3, then that's the 1 over 3 power, etc. And then minus a, we took out the a, so that's minus 1. All right, why did I do that? You see, if now we put infinity to a here, we get infinity, and then times, well, just put x, and then we have the infinity to here, so it's 1 over infinity, and then minus 1. All right, so this right here, work this out first. 1 over infinity gives us 0 for limit. So we have infinity times x to the 0th power minus 1. X to the 0th power is just 1. So this right here gives us infinity times 1 minus 1. 1 minus 1 is just 0. So this is infinity times 0. Oh no, this right here is an indeterminate form. Even worse, this is the indeterminate form that we really don't like. Indeterminate form is okay, only if it's 0 over 0 or infinity over infinity. Those two, we like it much better because we can use L'Hopital's rule. So we are going to see how we can somehow change this to the 0 over 0 or infinity over infinity in order for us to proceed. And we can actually do so by working with this a right here. Let me write it down. We have the limit as a approaching infinity. For this a here, and this is the usual trick that we can do. I'm going to bring this down to the denominator, So usually I say we'll bring this down. What I mean by that is the following. So originally it's on the numerator. Bring it down. You get 1 over a on the bottom like this. And then the top is still the same, x to the 1 over a minus 1. Now, why is this true? Well, if you look at this backwards, if we have 1 over a, well, how can we simplify this? One way to do so is top and bottom multiplied by a, and you see this did not cancel, so we just get a back, and we're just doing this backwards. And the beauty of this is that if we put infinity to here and here, on the top, you get x to the 1 over infinity minus 1. We saw that earlier, gives us 0. And then on the bottom, 1 over infinity, that gives us 0. And this is the indeterminate form that at least we prefer compared to the other one, like the 0 times infinity. So here we go. Because this is a 0 over 0 case, we get to use L'Hopital's rule. So that means we will have to differentiate the top with respect to a next, a. Because the question says so, we have to use a, and then do the same on the bottom. So this right here is the limit as a approaching infinity. Let's do the bottom one first, right? Taking the derivative of that, well, that's just taking the derivative of a to the negative 1 power. And to do this, use the power rule, right? Bring the power to the front, minus 1. And that will give us negative a to the negative 2, which is negative 1 over a squared. So that's nice, negative 1 over a squared. All right, now, this is the trickiest part of this question. Taking the derivative of x to the 1 over a's power minus 1 with respect to a. So a is the variable. And let me write this down to make it super clear for you. We have the x, which is like a constant in this case. So how do we take the derivative? Notice that the a is in the exponent, so this is kind of like an exponential function. And to take the derivative of this, well, we don't like to have base x. We like to have base e. Whenever the variable is in the exponent, we like to have base e. So let's change that. We can rewrite this as, well, I really want to put down the e. And remember, e and ln cancel. E raised to the ln of x power, they cancel, we still get the x back. And then raised to the 1 over a power. Alright, now we can multiply the exponents. This right here is dA of e, and then we just multiply them, so we have 1 over a times ln x. Now, how do we take the derivative of this? Derivative e to the whatever always repeats, right? So just put that down right away. E to the 1 over a times ln x. And then use the chain rule. This right here, right? This is like a number, so we have to multiply by the constant multiple, so multiply by ln x. And then the derivative of 1 over a is what? Derivative of 1 over a, which is the same as a to the negative 1, which is the same as that. So that will give us negative 1 over a squared. This part is from here, it's from here, it's from here. So this part is the same as x to the 1 over a power. And then you multiply by ln of the base. Ln of the base. And then lastly, you multiply by negative 1 over a squared. So it's because of this. You can go from here to here, and just have to remember, you keep this, because this is kind of like an exponential function in the a world, and you will multiply by ln of the base, right? So the formula that I'm using, or the formula that you can use is this. If you have dd a of some number b to the eighth power, this and that are the variable, right? So exponential function, this right here, it's the same as b to the a times ln b. Just like that. Or another version is, of course, this is the one that we are more familiar with. B to the x. This right here is just b to the x times ln b. This right here is confusing because the limits a approaching infinity, so we're taking the derivative with respect to a. So hopefully this part is clear. If so, let's go ahead and put that down right here. X to the 1 over a times ln x times negative 1 over a squared. And this works wonder. Because this and that cancel out completely, then go ahead and put the infinity into the a. So we are looking at x to the 1 over infinity times ln x. 1 over infinity is 0. X to the 0th power is just 1. So final answer is just ln x. Just like that.